Assalamu alaikum. I am Omar Wael, a teaching assistant at Computer Science and Engineering Department at AUC. Today, I will talk about most popular searching algorithm. Let's check our outline. Our first algorithm will be a linear search, and our second one will be a binary search. We will compare between them in order of implementation and complexity. Okay, this will be a theoretical video and there will be another video for implementation. Let's check our first algorithm. Linear search is a sequential searching algorithm, and it's the first idea came to us when thinking about search in a list or in array. Also, it's known as a brute force way to searching for a keyword inside list. Let's check or let's explain how it works with an example. At first, our desired value is k equal 1 and our list is the following. We will iterate over every item of our list and make a comparison step between the list items and our desired keyword or desired value. Until the condition became true, we will return the index of the item that make the comparison step successful or true. Otherwise, it will return -1 or -1, which means that our desired value is not exist in our list. Okay, so we start at index 0 and compare the value of this index with our desired value to not equal to 1. So we go to the next item and compare 4 with our desired value and it will not equal. So we go to the next item and the same at k equals 0. K is not equal 0. 1 is not equal 0. So we go to the next step and finally we stop at the fourth item, which is equal to our desired value. Okay, it's a symbol, and let's check the implementation of it and the complexity. The implementation is a very straightforward, which is just a for loop or looping over the list item by item and make a comparison step. Okay, the complexity will be divided into a two way to calculate the complexity. The first one is time and the second is space. We didn't use any etc spaces or data structure in our searching algorithm as we see in the pseudocode. So the space complexity will be big O of 1 and the time complexity is calculated by how much steps or how much steps that our algorithm takes to find or to finish its job. Okay, and we iterate over all the array item until we find or not find our desired value. So the time complexity will be O of 1. Sorry, O of n, big O of n. And n is the length of the list. Okay, and we use linear search in a smaller arrays or smaller data structure. Let's check our second algorithm and more complex algorithm, it's and more efficient algorithm than linear search, which is binary search. It's also have another names like half interval search or algorithmic search. Okay, and this algorithm uses a three indices to iterate over our list till find our desired value. At first, we have a low and high indices, which initially initially will be the first item in our list, which is low, and the highest or the last element in our list, which is high. And our third index will be a mid, and it's calculated based on low and high. Okay, and our comparison step will be over the mid, the value of item in the middle index. Okay, and the equation of mid will be as you see. How it works? At first, we compare our desired value with the current mid, and if it is equal, we will return the index of this mid. Okay, and if it is not equal, we will change the places of low and high. Okay, if it's more than or greater than our middle value, we will we will go or focus on uh, the right side of our the right array or the right partition of the mid. And if it's lower than the middle value, we will go to the first or the first partition of our array. And we have here compared 4 with 6, and 6 is greater than 4. So we focus on the first partition of our array and change the value of high to be -1 of the middle. And after we calculate the middle, it will be here, like we see, and we will focus only on this partition and ignore the second part of our list. After we compare with the mid, and we by luck here find our mid, our index of the desired value. The implementation will be two methods. The first one is iterative, and the second is recursive. Initially, we do we making like do until the pointers low and high meet each other. It's a pseudocode of our iterative method. As we see here, the equation of the mid each time it's calculated, and we make a three comparison at first. If the desired value equal the value in the middle index, we will return that our index will be the mid or the middle. And if we compare, if we find that our desired value is greater than the value in the middle, we will update the low index to be after the middle by 1. And otherwise, we will update the high index to be before our middle index by 1. And we will explain more the difference between iterative and recursive way in the demo or in the next video. The complexity of this algorithm, we will talk also about space complexity and the time complexity. The space complexity will be O of 1 like a linear search. Since we didn't use any etc. spaces to compare. But the time complexity is more efficient than linear search, since it, in the worst case, will be a log n, which if we it changes the n by the length of the list, we will find that it will be less than the n itself. Okay, and finally, we will have another video which we will implement both algorithms in Python. Thank you for watching.